In recent months, it has become increasingly clear that Elon Musk is making a strategic bet not just on artificial intelligence, but on its physical embodiment in the real world. And the key element of this strategy is the Tesla Optimus project, which is gradually transforming from an experimental prototype into a full-fledged product line of the future. According to several authoritative publications, including Bloomberg and Reuters, inside Tesla, the company is currently working not on a single robot model, but on several versions at once, each of which will solve specific tasks, ranging from everyday scenarios to heavy industry. And if earlier Optimus was perceived more as a demonstration of capabilities, now everything indicates that Tesla is preparing to bring robotics to the mass market, and much faster than many expected. One of the most discussed directions within this lineup is the so-called Optimus Cyberbeast, a name that clearly refers to Cybertruck and emphasizes the philosophy of brute force, industrial power, and maximum performance. According to insiders, this is a fundamentally different version of the robot, designed not for careful everyday tasks, but for heavy physical work in conditions where a human is either inefficient or cannot work at all. These include factories, logistics hubs, construction sites, extractive industries, and even potentially military infrastructure. Speaking about the expected characteristics, Optimus Cyberbeast may receive a completely redesigned drive architecture with increased torque and reinforced actuators capable of withstanding extreme loads for long periods without loss of efficiency. Unlike the base version of Optimus, which is focused on human-like mobility and energy efficiency, Cyberbeast will be closer to an industrial exoskeleton, but fully autonomous. According to preliminary estimates, such a robot will be able to lift from 300 to 500 kilograms in the base configuration and up to 800 kilograms in an enhanced version with additional stabilizing modules. This is a level that already surpasses the capabilities of most humans and even specialized equipment in some scenarios. Special attention is paid to materials. According to rumors, Tesla is considering the use of new alloys based on aluminum, titanium, and composite materials, which provide both high strength and relatively low weight of the structure. This is important because the robot must not only lift weight, but also move with it while maintaining balance and precision of movement. In this context, the software component plays a key role, namely neural network algorithms that Tesla is actively developing based on its experience in autonomous driving. Essentially, the same approach used in autopilot and full self-driving is being transferred into the physical world, where the robot learns to interact with objects, analyze the environment, and make decisions in real time. It is interesting that according to analysts at Morgan Stanley, Tesla may use its own next-generation chips optimized for robotics tasks, which will provide a serious advantage over competitors. These chips will process massive amounts of data from sensors, cameras, and lidars, allowing the robot to act as accurately and safely as possible, even in complex conditions. And here it is important to understand that this is not just a mechanical manipulator, but a full-fledged system with elements of autonomous thinking, capable of adapting to different tasks without constant human intervention. If we talk about practical application, Optimus Cyberbeast could radically change the labor market in industry. One such robot could potentially replace from 5 to 10 workers under standard conditions and up to several dozen in scenarios where continuous operation without breaks is required. And if we take into account that the robot does not get tired, does not require vacations, does not get sick, and can work 24/7, then the economic efficiency becomes obvious. That is why many experts are already calling robotization the next stage of the Industrial Revolution, comparable in scale to the introduction of electricity or automation. At the same time, Musk has repeatedly stated that in the long term, the number of humanoid robots could exceed the number of people on the planet. And while earlier this sounded like a futuristic hypothesis, now such statements are being taken much more seriously, especially against the backdrop of companies such as Tesla, Figure AI, and Boston Dynamics, accelerating development and attracting increasing amounts of investment into this field. As for cost, opinions differ. According to insider estimates, the base version of Optimus may cost in the range of $20,000 to $30,000. However, the Cyberbeast version, with its enhanced characteristics and industrial positioning, will most likely be significantly more expensive. The range could be from $80,000 to $150,000 per unit depending on configuration. At the same time, for large corporations and factories, this may still turn out to be more cost-effective than maintaining a large workforce, especially in conditions of labor shortages in developed countries. The timeline for release is also becoming clearer. According to sources close to Tesla, the first limited batches of robots may appear as early as the 2026 to 2027 period, initially for internal use at Tesla factories, and then gradually enter the external market. This approach has already been used by the company before, when new technologies were first tested within its ecosystem and then scaled. And all of this is happening against the backdrop of a global trend that is becoming increasingly obvious. Robotization is ceasing to be a niche topic and is turning into one of the key drivers of the future economy. Countries and corporations are beginning to compete not only in the field of AI, but also in who can integrate this intelligence into the physical world faster. And in this sense, Musk's bet on Optimus looks not just logical, but strategically calculated. In fact, we are witnessing the beginning of a new race where the stake is control over a market that in the future could be worth trillions of dollars. And if Tesla indeed manages to implement all the stated plans, then Optimus Cyberbeast may become the very product that will finally cement the transition from digital AI to physical AI, changing not only industry, but also the very structure of society. And perhaps it is right now that we are at the point where the future stops being an abstract idea and begins to take on a very concrete metallic form. And if we look even deeper, the emergence of systems such as Optimus Cyberbeast could trigger a chain reaction across the global economy, because this is not just about replacing labor, but about a complete restructuring of production processes. Companies will begin to rethink logistics, factory architecture, and even the products themselves around the capabilities of robots, which means efficiency will grow not linearly, but exponentially. Already now, according to analysts at Goldman Sachs, the humanoid robot market could grow to hundreds of billions of dollars over the next 10 to 15 years. And a significant portion of this growth will be driven precisely by industrial solutions. And in this context, Optimus Cyberbeast looks like the first real candidate for the role of a de facto standard around which entire ecosystems will begin to form. The question is no longer whether such robots will appear, but who will be the first to scale their production to millions of units. And if Tesla maintains its current pace, it may be the company that not only entered the market, but effectively created it. Ultimately, Optimus Cyberbeast is capable not only of radically increasing global productivity, but also of opening the door to a new stage of human civilization, where the main limitation of development will no longer be physical labor, but creativity and the speed of innovation.